To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear grade 8 students. So today we are starting a new chapter, a new lesson. So this is the 14th lesson in your grade 8 science syllabus. So here we're doing some kind of a different one. Now in the earlier lessons we discussed several things regarding to the chemical reactions, then after that magnet, sound, several energy types like electricity, then after that we studied about anatomy lessons like the organ systems. Then after that we discussed about the plant biological processes. Then we discussed about the life cycles. But however, within this part or within this lesson, we are going to investigate or will be investigating about the outer space, my dear children. A rather somewhat interesting topic, right? Other than the previous ones. This is somewhat like an interesting topic. Here we are going to observe about the celestial objects and we'll be studying about the phenomena and explorations associated with the solar system. So all this lesson is going to reflect about the outer space, about our solar systems, constellation, planets, moons, and all the things related to our universe. Okay, phenomena related to our universe. So it's a quite interesting lesson, right? So as you know that our universe, if you take our universe, it's going to spread in a vast area. Even we don't know what is the end of our universe, right? What is the starting point of our universe? We assume that our universe is infinite, right? It's an infinite thing. So my dear children, will be discussing mainly about the planets and the celestial objects, how to explore these things, what are the modern trends or modern technologies used by man to explore these things, and we'll be investigating about our planet also, the planet Earth, right? Special properties of the planet Earth. And after that, not only the planet Earth, we'll be discussing about the other planets as well. Their moons, right? I think you have heard about the moon, right? So not only the planet Earth, even the other planets also have different moons. So we'll be investigating about those things. We'll be discussing several information regarding to these planets and other celestial objects contained within our universe, right? So the 14th lesson, my dear children, is a good and a quite interesting lesson part. Here we are discussing mainly about the celestial object contained within the solar system and within our universe. So my dear children, let's move on to see what are the main topics under this 14th lesson. What are the main topics and main information, what are the main topics and what are the main things that we are going to learn. Okay, so let's move on to see what are the main things that we are going to learn within this lesson. So these are the main topics that we are about to learn within this lesson, my dear children. First of all, we'll be learning about the solar system. So I think you already know what is our solar system is. If you take our solar system, right? Solar system is the system that contains our planets. Our planet means, now within, if you take Earth, so Earth is a planet. So the system that include with these planets is called as the solar system. So my dear children, before I'm going to, express, I'm going to ask you a simple question. How many planets are there in our solar system right now? How many planets are there? And do you know the names of these planets? So in the earlier times, like in the earlier time means, like when you take in the 19th century to 20th, starting of the 20th century, right? There was 9 planets. There was 9 planets within our solar system, right? Now, however, one planet has been expelled from our solar system recently, the planet called Pluto. So therefore, now within our solar system, there is only 8 planets. There are only 8 planets right now. Okay, so the planetary system, or the planets that includes, right, the planets which includes within our solar system is referred as the solar system. Not the actually, it's not the it's not in the solar system, but however, now if you are going to define the solar system, we can say that the system of planets which included within our including our Earth can be considered as the solar system. Okay, so there are 8 planets. In the earlier there was 9 including Pluto, but however, due to a special reason, Pluto has been removed from our solar system because it's not been considered as a planet, as it takes somewhat longer time to revolve around the sun, right? So that's the main reason for expelling Pluto. So you will find furthermore details regarding the expelling of Pluto if you refer the internet. Okay, it happened like recently, between 10 to 15 years back. Okay, it happens recently. So find out more details about the Pluto. Okay, I just mentioned what is the solar system is. So we'll be studying about the solar system and the planets and the moons that has for each of these planets, and the distances from the sun, and several other information regarding the solar system. So within the solar system lesson part. Then after, we'll be moving on to seasonal changes, occurrence of seasonal changes. How does the seasonal changes occur in our Earth? You know that there are several seasons, right? For Sri Lanka, we don't, if you take Sri Lanka, for Sri Lanka, as it is a tropical country, we don't have seasons, right? But however, when you take countries like New Zealand, Australia, USA and England, those kind of countries which are away from the equator of the Earth, those countries, there are a lot of other countries as well, but however, I have just mentioned several, right? So those countries, the countries which are somewhat away from the equator, not the tropical countries, okay, not the tropical countries, countries which are away from the equator, up top and bottom, both. So those countries, they usually go around with, now if you take a year, within an year, they face several seasonal changes. For one season, they get snow. For one season, they get plenty of sunlight. Like that way, there are 4 seasons, right? There are several seasons actually. Okay, so we'll be discussing about the occurrence of these seasons. Okay, we'll be discussing about the occurrence, how it's going to, how a seasonal change is going to occur within our Earth. So we'll be discussing about those things within our second topic. Then after that, my dear children, number 3, important incidents associated with the solar system. So we'll be discussing about several important incidents that's going to occur within the solar system in our planets. So mainly we are focusing here about the if you take sun, moon and our earth, there are several phenomena which is going to occur, like solar eclipses, lunar eclipses. So we'll be mainly focusing about those kinds of incidents within this chapter, within the third chapter or the third main topic. So my dear children, after that we'll be discussing about the universe and how to explore the universe. What are the modern technologies used by the man in order to explore the universe? You know that the science and technology have developed up to a greater extent within this time period. Even it's been keep on going, keep on developing. So if you take the late 90s time period and the starting of the 19th century time period, there is a huge difference right now. Right? There's a huge difference. Like if you take the 19th century, at the half of the 19th century, like in 1950s, 1960s. So those are the years which took a base to explore the universe. Then after that in 1970s and 1980s, those years were the, right? Those years were the years that actually took these up to a, a reality. Scientists sent several rockets and spaceships to space to explore the universe. So the base which took at the half point of the 19th century became a reality during the 1970s and 1960s time period. And 1980s time period also took a huge step. Then that during those time periods, even the man explored the moon, right? Then several people went to space. International Space Station was created, right? So Russia and China and America, USA, those countries, right, they led these missions to explore the universe. But nowadays, now the competition is still going around. But nowadays, my dear children, there are several countries who are going to explore the universe, like in our neighboring country India also, right? Engage in different kinds of experiments and activities to explore the universe. So all of these things being developed by the man to explore the universe. So we'll be discussing about what are the modern trends and the modern technologies which are being used by the human in order to explore the universe. Okay. So after that, my dear children, we'll be discussing about artificial satellites. So if you take a satellite, so satellite is a man-made thing. Satellite help in different kinds of activities for the man. You know that you guys are using a mobile phone. Now, even to watch this video, sometimes you may use a mobile phone, a computer. So I think you know that there's a special thing called Global Positioning System, GPS. So GPS is going to work because of the help of satellites, right? The global positioning systems, those things are going to work because of the satellites. So sometimes if you take a mobile phone, you know that you guys use these mobile phones mainly to give out a call for a certain person or for a different kind of a person. And sometimes you use data network connections in order to get calls like WhatsApp, Skype, Viber and those kind of things. So in these cases also, my dear children, we use the help of satellites in triangulating these signals. Okay. So we'll be discussing about several things related to the satellites under the artificial satellites part. right? How a satellite is going to, like these things are built within our Earth, no? So how we are going to take this into the outer space, how it is rotating around our Earth. So we'll be discussing these things about the artificial satellite thing, right? Then finally, my dear children, we'll be discussing about the constellations, right? So we'll be discussing about the constellations finally, right? Star patterns that we can observe within our like night sky. If you look at the night sky clearly, you can observe several star patterns, and these things are the ones which are specially called as the constellations, right? Then after that, we'll be studying about the main constellations, and also, my dear children, there is another one called the zodiac, right? I think you know that each of you guys have a zodiac symbol. So we'll be studying about that zodiac thing as well within the final part of the lesson under the constellations, right? Then like in the previous lessons, my dear children, after the end of the lesson parts, or after the end of the theoretical parts, we'll be discussing several questions. First of all, we'll be starting the questions of your textbook. Then after that, we'll be discussing several questions related to the lesson, some extra questions, and we'll be finishing up the lesson. So this is our plan for the lesson number 14. So my dear children, now let's move on with our first and foremost topic. So within our first and foremost topic in this lesson, we'll be studying about the solar system. We'll be studying about the solar system, right then. So the solar system. So before we are going to start about the solar system, my dear children, let's get a brief idea or a simple introduction about the lesson part. So a simple introduction is given. Let's see. A large number of celestial objects can be observed in the night sky. From ancient time, people were curious about those celestial objects. They gathered information by observation of those objects. So, large number of celestial objects. Celestial objects means, my dear children, these are the objects that we can observe within the night sky, like planets, stars, satellites, rockets even. Then if you take, the meteoroids, okay, all of these things, meteoroids and even comets, all of these things which can be observed within the night sky are referred as celestial objects. So there are large number of celestial objects in our universe. When you check the night sky, you can observe these things. Okay, you can clearly observe these things. If you are very lucky, then you may also observe some falling stars and comets also. But however, these things are very rare, my dear children. Those comet thing and falling stars are very rare. It's very rare to observe. And even the solar eclipses and lunar eclipses, those things are very rare to observe. Okay, those things are very rare to observe. Lunar eclipses are, those things are occurring in our planet or within our planet quite often. However, you won't have any idea about that thing. However, it can occur like once or twice a month can occur, lunar eclipses, right? But however, solar eclipses are not that much, it's not occurring that much often, solar eclipses. However, the lunar eclipses can be observed within once or twice a month, sometimes. Okay, sometimes twice a month. But however, if you check if you check the lunar eclipse, like the moon in a full moon day, right, you might observe that the color of the moon is somewhat different in some days. Usually when you check the moon, you can observe it as a like pale yellow color, right? It's kind of a pale yellow color object. But however, during some, right, only not in every time, but in some full moon days, right, you might observe that this color is getting changed somewhat. It's because of the eclipses. So even though the eclipses are occurring, I mean, like if you take lunar eclipses, even though these things are occurring at an often time period, but however, solar eclipses are not like that. Okay, so once again, my dear children, if you observe the night sky, you can observe several celestial objects, and they gather information by observing those objects. So in the earlier time period, man or people, they observed these things and they gathered several information. So these information were really important for the modern scientists as well. Based on those informations, they are the ones who carried out different experiments to find out whether these things are correct or incorrect. Okay, so those earlier or the previous information was very important in order to develop this kind of a technology regarding the universe. Then ancient people observed celestial objects with their naked eyes. So we know that ancient people, they haven't got any special instruments at that time period. So therefore they observed the celestial objects or the night sky by using their naked eye, right? Then like scientists like Galileo Galilei, those were the people who invented several instruments like the telescope, right? Then Nicholas Copernicus, right? So those people invented several instruments after that in order to observe the celestial objects. But however, if you take the time period even before that, ancient time period, very ancient time period, so in those time periods, my dear children, people use their naked eye and they gather several information by just looking at them. Okay, so those information are quite important, right? Those information are also quite important for the development of this technology and for the field also, right? Then later on, various instruments were used for this purpose. So like I said, later several instruments were used like telescopes, manned and unmanned spacecrafts. So manned means manned spacecrafts. That means, my dear children, spaceships that had man or humans, right? In the earlier time period, people sent or scientists sent different kinds of spaceships, but however unmanned. There was no human. I think you have heard about that spaceship that sent a dog, a female dog called Laika, to the outer space by the Russian people, right? So by that way they tested or they investigated about the outer space, the conditions of the outer space. So directly we can't send a human being to the outer space. No, we don't know what are the conditions. So in order to investigate those conditions, my dear children, first of all, unmanned spacecrafts were sent. Then after that, manned means that spacecrafts with people were sent to the outer space to explore. Then telescopes are also a type of an instrument that used to observe the outer space. Even for now, within our Earth, there are very powerful telescopes, and even in the outer space also there are very powerful telescopes, right? like the Hubble telescope, James Webb telescope, right? Those things are in the outer space. So the information received by those instruments are being gathered here and collected, and more, like more images with more resolution and videos were given to you guys by using those telescopes. Okay, so those things are also pretty much important for the development of this field, right? Okay, due to the information collected since ancient time, now we have the ability of understanding the solar system, which is a large system including the Earth. Still, the explorations are being carried out about this. So, my dear children, based on those earlier information given by the several scientists and also by our ancient people, right? So, based on those information and by gathering new information, like information received by telescopes and different kinds of machines, now my dear children, we know, like, not all, right? There is no way to identify or no way to find out all the information regarding these things, but however, my dear children, up to like certain extent, we know a bit of the, like, small bit, we know like a small bit of a bit of our solar system. Okay, there are like several things, even more larger things to learn about these things, but however, still the explorations are going to be held by from different scientists. But however, from those informations collected by the ancient people and from new information collected by our scientists using our instruments, different instruments, we have like some kind of a summary about our solar system. So it's the planetary system that contained our Earth and the other planets. Solar system is that. Okay, so my dear children, as you can see here within the figure, now you can observe the solar system. So the solar system is going to start with the planet Mercury. Within this figure, you can observe the planet Mercury is the first and foremost planet which is closest to the sun. So sun is the energy source. So that's a huge energy ball actually, right? As you can see here, sun, there are nuclear explosions or nuclear reactions which are going to occur within the sun. Actually, sun is not burning over there, right? Remember, sun is not burning. In order to burn, there should be oxygen, right? There should be oxygen gas in here. How you can see that if you check this figure and over there this figure, both the figures, here you can see that, right? Sun is like in a yellow color object, like it's burning. But however, sun is not burning here, my dear children. Always remember, sun, if you take the sun is not like a fireball and there is no fire at all. Those things are nuclear reactions. If you take our sun is showing nuclear reactions. Okay, it's not a burning fireball, remember it. Okay, sometimes your friends or any other may ask whether the sun is a fireball. Oh, even though oxygen gas is not there at the outer space, how does the sun is providing that much of fire? Actually, it's not fire, my dear children. So remember, it's not fire. Those things are nuclear reactions, right? Those things are nuclear reactions. So these nuclear reactions are generating huge amount of heat energy and light energy. So that's the reason which you can observe sun as a fireball. Okay, right. So my dear children, we'll head on to the planets once again. First planet is the planet Mercury. Planet Mercury is the one which is closest to the Sun. Planet Mercury is the one which is very closest to the Sun. Mercury. And also, if you check the size of the Mercury planet, when you compare it with the other ones, my dear children, it is somewhat smaller than the others. Okay, it is somewhat smaller than the others. See, you can, if you check this figure, you can see it very clearly. The planet Mercury is, even though it is very closer to the Sun, it's very, when you check the size, it's very small. Okay. Then, my dear children, you can observe the second planet. The second planet in our solar system is the planet Venus, right? So, planet Venus is somewhat greater than the Mercury, okay, and it is the second planet from our Sun. Then after that, my dear children, you can observe the blue planet over here, the blue color planet, the third planet in our solar system. This is the planet that we live in. So this is the planet, my dear children, that we live in. So this is our planet Earth. So you know that if you take the solar system, planet Earth is the only planet that has life, right? Planet Earth is the only planet that has life. If you take any other planets, there are no any life. Life is not there. There are no any organisms. If you take these 8 planets, planet Earth is the only one that has life, that has organisms, right? Even the water is not there. Up to now, we haven't found water, right? We don't know whether in the near future we can find it or not. But however, up to now, we assume that, up to now we gathered several information. So if you check those information, there is no planet with water. There is no planet with water. Only the planet Earth which has water. Okay, only the planet Earth that has water. So third planet from our Sun is the planet Earth. So that's the planet that we are living in, and it's the only planet that has life in our solar system. Then, my dear children, you can observe the fourth planet, the planet Mars, right? So you know that there are several controversies going around in our in our Earth, okay, that the Mars, planet Mars, it has water and it had life in the earlier times. But however, there was no proof. Still there was no proof, right? Still the scientists are going to investigate about those facts. However, there was no trace of life forms within the planet Mars. Still the explorations are going on, but however, there is no, right? Up to now, there is no any clue regarding the water or any other life forms within the Mars. So even though there were several controversies going around in the Earth, right, among the people on the Earth, but however, up to information that we have gathered right now, according to the information that we have gathered right now, right, there are no forms of life within the Mars. Okay, there are no forms of life within the Mars, right, and there are no any forms of water also within the Mars. So it's like a rocky planet, a dried out planet. Planet Mars. Okay, right. Then the next one. After planet Mars, you can observe the largest planet. The largest planet in our solar system. Planet Jupiter is the largest planet contained within our solar system. There's a specialty in Jupiter, my dear children. If you take the planet Jupiter, like our Earth or Mars, you know that our Earth has a crust. Okay, our Earth has a crust, Earth crust. So we can set foot like this, we can stand without any trouble because the crust is very strong, right? It's made up with solid particles like sand, mud or soil. But however, if you can go to planet Jupiter is a planet that contains dust particles and air particles. Okay, there is no crust like this. So you will not be able to stand on planet Jupiter like this. You won't be able to do that. Okay, you won't be able to do that. Even though it is a very larger planet, there is no crust in it. Planet Jupiter, it doesn't contain a crust like the planet Earth. So the information collected on the planet Jupiter reflects these things, my dear children. Okay, information collected about the planet Jupiter reflect these things. Okay, so this is about the Jupiter. Jupiter is the largest planet that we can observe within our solar system. Then the next one, Saturn. Saturn is the second largest planet in our solar system. And my dear children, you know that there are several rings around the planet Saturn. So it is giving out a wonderful, like a beautiful outer look for the planet Saturn. Okay, so this is Saturn. We consider planet Saturn as the most beautiful planet from our solar system. Okay, as it has several rings which are made up with dust and other particles. Then my dear children, when you go further, you can observe planet Uranus and finally planet Neptune. These planets are somewhat colder planets. It's because that these planets are like very far away from the sun. Okay, so after the Neptune, my dear children, there was another planet called Pluto. So I told you that Pluto has been expelled, right? So it's not been mentioned here. So we don't consider now, within this time period, we don't consider Pluto as a planet, right? Main reason is it's taking somewhat longer time period in order to revolve around sun. So we'll be discussing about what the revolution is. Okay, just for now, you remember to complete one cycle around the sun, it takes very much longer time. So therefore, Pluto was expelled from our solar system. So these are the planets that contain within our solar system and several information regarding these planets, my dear children. Okay, so what are the planets once again? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. So you can observe the planets in the second picture quite clearly rather than the top one. Okay, so these are the planets that contained in our solar system. Right. So my dear children, we'll be studying about now. So I told you about that revolution thing. When you are discussing about the planet Pluto, it's actually not a planet. That's a celestial object. You refer that thing as a celestial object. So when you are discussing about Pluto, I told you about a certain term called the revolution. So now we'll be studying what this revolution and a rotation means. So as you can see here within the figure, you can see that the sun is there at the middle and this is a planet. So you know that each and every planet, it's going to rotate around itself. It's going to rotate around itself, right? So it's like this. If I am a planet, then you know that I can rotate like this. So when I am rotating like this, it is called as just a rotation. So this is a rotation, right? It's simply a rotation. So the rotation is mentioned from this greenish arrow, and this is the planet. So planets rotate around their own axis. So around my axis, symmetrical axis, you know, like I can rotate like this. So this is a rotation. So planet is always rotating only to one direction, one certain direction, not to the either it is going to be to your right hand side or to left hand side. That's it. It's not rotating to here and there, both the sides. Okay, it is going to rotate just only to one certain direction. Okay, so each and every planet is going to rotate. Each and every planet in our solar system is going to rotate. Okay, so it has a rotational axis. It has a rotational axis. Around a certain axis, it's going to rotate, like in the given figure. So over here you can observe it. So while revolving around the sun, right? While revolving around the sun, so what do you mean by revolving then? Revolution means, my dear children, rotating around a certain object. Rotating around a certain object while it is keeping rotating around itself. While it's rotating around itself, it's going to rotate around a certain object. So that is called as revolution. Simply, now this is the board. So this is me. When I am rotating like this, I am going to rotate around the board like this. So if so, then it is a revolution. While I am rotating, while I am rotating around myself, I am also going to rotate around the board. Okay. So that kind of a movement can be considered as a revolution. So here you can clearly observe that rotation, and while it is rotating, it's gently going to move around this path, which is the sun, here the sun, and gently it is moving around the sun like this. Okay, while it is rotating, it's moving around the sun. So that is called as revolution. That is called as revolution. Then, rotational time of a planet is the time taken by the planet to turn once around its own axis. So, rotational time of a planet is the time taken by a planet to turn once around its own axis. What do you mean by that? Now I am rotating like this. Okay, so like this I can rotate. So like this I can rotate. So the time taken by me to complete one cycle around me is called as the rotational time period. It's very simple, right? Once again, so this is me. So I'm going to rotate around myself like this. So now I have completed one cycle, one circle. Okay, this is the starting position. So I have rotated like this. So when I'm going to rotate like this, now I have completed one cycle. One cycle. Okay. So once again, see, it's very simple. You rotate like this. So, right. And I'm going to come back. I have completed one cycle. So time taken to complete that one cycle, my dear children, is called as the rotational time period. Okay. The rotational time. It's very simple. So rotational time of a planet is the time taken by the planet to turn once. So here you can see the blue planet over here. When it is going to rotate like this, one certain cycle, the time taken for a one cycle by this planet. Okay, by this planet, the time taken to complete one single rotation is referred as the rotational time of the planet. Rotational time. So it is the time span of a day of that particular planet. Now, if you take the rotational time, my dear children, rotational time is the time considered as a one day within that planet. Okay, a day means, one day means the time taken to rotate around itself, right? But however, only one cycle. So we can say it more clearly like this: time taken by a certain planet to complete one cycle around its own axis is called as one day within that planet. Why it is mentioned as within that planet? Because, my dear children, for each and every planet, the time taken by that particular planet to rotate around itself is going to differ. You know that our Earth has 24 hours within a certain day. Our Earth has 24 hours within a certain day. However, if you check the rotational time period of a different planet, it's going to change. Okay, it's going to change. For planet Earth, it's 24 hours. But in different planet, it's going to change. Sometimes it can be greater or sometimes it can be lesser also. Right? So my dear children, this is considered as a one particular day. One day. So one day means actually, it's the time period taken by a certain planet to complete one cycle around its own axis. Okay, that is, what do you mean by a one day? So here example is also given. The rotational time of the Earth is 24 hours. So that is a day of the Earth. Right? So our Earth, it has 24 hours of a rotational time. That's the time taken to complete one cycle around the Earth's axis. Right? Like when I'm going to rotate, I'm going to take like 3 or 4 seconds. No, let's count. So this is me. So I'm going to complete one cycle now. And we'll count the number of seconds. So 1, 2, 3, 4, 5. Now my rotational time is like 5 seconds. My rotational time is like 5 seconds. Okay, so if I am a planet, then my day is just like 5 minutes, 5 seconds, right? 5 seconds. If I'm a planet, then my dear children, within my planet, 1 day is exactly equal to 5 seconds. So it's very simple. Okay. So for planet Earth, it takes around 24 hours to complete a one cycle around itself. So therefore, the rotational time of planet Earth is 24 hours, and within Earth, 1 day is equal to 24 hours. Okay, right. Then, time of revolution of a planet is the time taken by the planet to revolve once around the sun. That is the year of that particular planet. Example, the time of revolution of the Earth is 365.25 days. That is the year of the Earth. Now if you take the revolution, my dear children, revolution means the time taken by a certain planet to complete one cycle around the sun. Each and every planet is rotating around the sun. No, actually it cannot be considered as a rotation. It is also it is called as a revolution. Okay, it is called as a revolution. So when I'm going to come to our next passage, we'll discuss about the revolution in detail. Up to now, you just completing one cycle or rotating around a different object. When a planet is going to rotate around, now this different object is the sun at our solar system. So when a planet is going to rotate around the sun, and when it is going to complete one cycle around it, 1 year is going to pass. So for that planet, 1 year is considered as the time taken by that particular planet to rotate around the sun. Okay, to rotate around the sun. So when you take planet Earth is going to take 365.25 days to complete one cycle around the sun. Okay, around the sun. 365 days and 365 days plus another somewhat 0.25. Okay, 0.25 means 1/4 of a certain day. Okay, 1/4 of a certain day. So 365 and 1/4. Okay, that's the entire time taken by our planet Earth to revolve around the sun, to complete one cycle around the sun. Right then. So now let's see, my dear children, what does this revolution actually means? The correct definition. Consider a dancing event by a dancer to understand the concept about rotation and the revolution. A dancer rotates around its own axis. It's called the rotation. So dance, when you take a Canadian or traditional dancer, you know that dancer is going to rotate like this around itself, right? Around himself, right? Like this. Okay. So that is called as a rotation. However, my dear children, while the dancer is rotating around himself, see, at the same time, the dancer revolves around an imaginary point on the stage. This is called the revolution. At the same time now, dancer is going to rotate around a different imaginary point. So that is called a revolution. So revolution means, actually, the correct definition for revolution is rotating around a certain object while rotating around itself. So as you can see here, the dancer is going to rotate around itself and also it's going to, while rotating, it's going to revolve around a certain point. So in the same way, the planets are also going to rotate and revolve around our sun. Okay, planets are going to do the same thing. Planets are going to rotate around itself, and also it's going to rotate around our sun while keep rotating around itself, okay, not by stopping it. So that kind of a motion is referred as a revolution. A revolution. So rotation, it's keep on rotating, the dancer keep on rotating, and the revolution, while rotating, it's rotating around a different object, like this. Rotation and revolution. Okay. So each and every planet in our solar system, it rotates, and also it's going to revolve around the sun. Okay. So the time taken by a certain planet to complete one cycle around its own axis is called as one day within that particular planet. The time taken by a planet to complete one cycle around the sun while it is keep rotating around itself is called as 1 year of that particular planet. 1 year. Okay, 1 year. So day means time taken to complete one cycle around itself. Year means time taken to complete one cycle around the sun. Remember, it should rotate around itself. Okay. So this is the year and day for a certain planet, my dear children. Right then. So we'll move on with the next thing. So planet rotates around its own axis. The path along which a planet revolves around the sun is its orbit. Right? So I'll take the previous one once again to show that orbit. Right, now this is considered as the orbit. The orbit. Always the planet is moving around the sun on a constant path like this. So this path is called as the orbit of the planet. Orbit. Okay. So orbit, my dear children. So now I can draw it to you like this. So this is the sun. So we'll draw it like somewhat larger. So this is sun. Right? And this is the planet. So it rotates around itself, and it's going to move around the planet, around the sun like this. So it's rotating around the sun like this. So this constant path with which the planet is going to move around the sun is called the orbit. For each and every planet in our solar system, it has a unique, right, identical orbit. Around that orbit or around that path, the planet is going to revolve around the sun. Planet is going to revolve around the sun. So this is this path in which the planet is going to rotate around the sun is considered as the orbit. Orbit. Right? All planets have a tilt to its orbital plane when revolve. Now the next thing is that each and every planet, it has a tilt. means that the planet is not going to move like this. Planet is showing some kind of a tilt. So actually it's going to rotate like this, my dear children. Okay, it's going to rotate like this. So this is the orbit. This is the horizontal axis of vertical axis of the orbit, the original vertical axis. However, it's going to rotate like this. Okay, it's like this. This is me. I'm going to rotate around myself. Then while I'm revolving around the board, I'm going to revolve like this. Not like this. This is me around my line. But when I'm going to rotate around the board, I'm going to, like show some kind of a tilt. So then I'm going to rotate like this and I'm going to rotate around the board. So it's really simple. That's how a revolution works. Always each and every planet show this kind of a tilt when it is revolving around the sun. Okay. So remember, all planets have a tilt to its orbital plane when revolve. Example given, the Earth has a tilt of 23.5 degrees. 23.5 degrees. The perpendicular axis of its orbital plane. Now you can see within the given figure, right? If this is planet Earth, my dear children, the angle in here, from here to here, the angle is 23.5. Okay, 23.5. Actually, it should be tilted to the other way around, but I have drawn it like this. So if you want, I can change the direction. It's very simple. So we'll change it so that you can get the exact idea very clearly. So the thing is that, my dear children, as this is a planet and as it is a, like an exact circle-like object, we can't observe the tilt. I mean, the object is symmetrical, no? So therefore, we can't observe a tilt if I'm going to draw a 2D figure like this. Okay? But however, I hope that you may take the idea about this tilt thing. So it's not like this. It's like somewhat slanted to the other side up to like 23.5 degrees. Then it is rotating. See, this is the Earth. So this is rotation. When it is going to revolve, it's going to revolve like this. Like somewhat slant. Not like in a vertical position like this. Like this. It has some kind of a slant. So when it is revolving around the orbit, it's showing some kind of a slant. That is called as the tilt. The tilt. Right then. So the orbit and the tilt. So my dear children, if you take the tilt, is there any kind of an importance on this tilt? Right? Now we'll check about the planet Earth. If you take planet Earth, what is the importance of having this kind of a tilt? Right? What is the importance? The main importance is, my dear children, when there is a tilt like this, okay, it helps to receive solar energy very well to all around the corners. See? All around the corners, solar energy is being received right, very well when there is a tilt. But if it is like this in a vertical position, then my dear children, distribution of solar heat or solar energy is going to reduce for the top and bottom parts. So it's an added advantage. This tilt is very important for the distribution of energy, solar energy, heat energy to our earth. Okay, so this tilt is very important. Okay, so each and every planet has this tilt. Right then. So my dear children, there are subplanets around most of the planets. They also rotate around their axis while revolving around the planet. Specialty is that Mercury and Venus have no subplanets. So my dear children, there are subplanets. Subplanet means if you take our planet Earth, we have a subplanet. These subplanets are also called as moons. Right? So our Earth has one planet or one subplanet called the moon. Okay, just a one. So you know that moon is rotating around planet Earth. So these subplanets are also rotating around the planet, that particular planet. Okay, it's rotating around a particular planet. Specialty is that Mercury and Venus, they do not have moons or subplanets. Mercury and Venus, they do not have subplanets or moons. Right, so a table is given for you guys to study about the revolutional time, rotational time, the diameter of the planet, distance from the planet in kilometers, the tilt to the orbital plane, and number of subplanets contained. So we'll study about this table then, my dear children. So the first and foremost thing, or the first and foremost planet is planet Mercury. So distance from the sun given kilometers in kilometers, but check the other one also, right? Kilometers, millions. So 57.9 millions of kilometers is the distance from sun. So even though it is closer, it is the one which is closest to the sun. See, it's away like 57.9 kilometers, but not just kilometers, millions of kilometers. So it's very large value, right? A very large value. So Mercury is away from the sun 57.9 millions of kilometers. The diameter, if you take the diameter of the planet Mercury, 4,879 kilometers. Rotational time, this is compared to the Earth days, right? Compared to Earth days. Okay, when you take the 1 day of Earth, right? When you compare it with the rotational time of the other planet, right? How many days will it be taken by the other planet to complete one particular rotation? Okay, so when you compared with our Earth, right, the Mercury is going to rotate around itself by taking 58.65 days. 58.65 days. So it's taking nearly 59 days. Okay, we can round it off to 59 now. So nearly it's taking 59 days to complete one cycle around, right, around itself. Then revolutional time in Earth years, given, right? So it's very less, 0.24, right, 0.24. So the number of days taken to complete one cycle around the sun, you just take 0.24 and multiply it by 365 to calculate the number of days taken by Mercury to complete one revolution around the sun. Okay, Then the next one, tilt to the orbital plane, it's 0.1 degrees. Tilt is very less for the Mercury, and there are no subplanets. Okay, there are no subplanets. As you can see here, it's been mentioned till 2016. Till 2016 means up to 2016 there was no. Okay, we don't know after that we may find out any subplanet or not, but however for Mercury and Venus we won't be able to find, because already it's been investigated and these informations are correct, my dear children, up to a greater extent. So I don't think we will be able to find out any subplanets for Mercury and Venus in the near future also. But however, these values might change for these guys at the bottom. For these planets, these values might change in the future. We don't know for exact, right? That's why it is given as till 2016 over here. Then next one, the next planet is planet Venus, 108.9 millions of kilometers from the Sun. Diameter is around 12,104 kilometers, and the rotational time is like 243 days. It's like an year, right? Near to a year. Then the revolution time is 0.62 revolutional time. Then tilt to the orbital plane is 177.4 degrees. It's almost, my dear children, a straight line. I mean, like the angle is almost like a straight line. Means that if this is the Mercury, if this is planet Venus, then it's revolving around the planet. Then it is revolving around the Sun, not like that, like this. If 3 degrees are going to be added, then it's revolving like this around the Sun, not like this, like this. Right then. Then the next one, subplanets, there is no subplanet in it. Then the next one, Earth. So our Earth is like 149.6. We'll round it off and we'll take 150. So 150 million kilometers away from the Sun. 150 million, about 150 million kilometers away from the Sun. Diameter is around 12,756. Somewhat greater than the planet Venus, right? Somewhat larger than the planet Venus. So we know that our Earth is going to take just 1 day to rotate around its own axis, then 1 year to rotate around the planet, rotate around the Sun. Then the tilt is 23.4, 23.5, 23.4. Then, my dear children, we have one subplanet called the Moon. Then the next one, Mars, 227.9 millions of kilometers. The diameter is 6,792 kilometers. It means it is somewhat a smaller planet. If you check the planet Earth, it is way more smaller than the planet Earth. So rotational time is also somewhat near to the planet Earth. 1.03 of time taken, 1.03 of days is taken. Then revolutional time somewhat greater than the planet Earth, nearly around 2 years, 1.88. Then, my dear children, tilt is 6.7 degrees and it has two subplanets. Then the next one, Jupiter. So planet Jupiter, it's 778.6 millions of kilometers away from the Sun. As you can see here, the diameter, now when you compare to the other values, right, the top values, it's showing a dramatical, very large value, the diameter. Now it's way more than 100,000. So it's showing 142,984. 142,984 kilometers of a diameter can be observed within planet Jupiter. Then my dear children, the time taken to complete one rotation is equal to 0.41 days. Then for one revolution, it's going to take 11 years, right? Nearly 12 years, 11.86 years or nearly 12 years. Then the tilt is 25.2 degrees and it has 67 subplanets. So that's the planet which has largest number of moons or largest number of subplanets. Then my dear children, after that you can observe Saturn. So 1433.5 millions of kilometers away from the sun. Then the diameter, as you can see here, also you can observe very large value, as it is the second most largest planet in our solar system. So 120,536 kilometers of a diameter can be observed within the Saturn. Then my dear children, it's going to take 0.44 days. 0.44 days, nearly half of a day, right? Nearly half of a day compared to the planet Earth, right? To complete one rotation. Then to complete one revolution around the sun, it's going to take around 30 years, 29.46 years to be in an exact, right? 29.46, almost 30 years. Then the tilt is given 3.1 degrees and it has 62 subplanets. Then Uranus, somewhat now far away, very far away from the sun, 2872.5 millions of kilometers. So the diameter is around 1118 kilometers, the diameter. Rotational time is around 0.72 days. And my dear children, it's going to take 84 years to complete one revolution. So as you can see here, when the planet is somewhat closer to the sun, it's going to take less time period. However, when it is moving away from the sun, it's going to take more time. It's because of the gravitational effect, gravitational force. Okay, when it is closer, it's going to face to a huge gravity. So therefore, it will rotate quite fast around the sun. However, when the planet is moving away from the sun, the gravitational effect given out by the sun is somewhat getting reduced. So therefore, to complete one revolution, it takes more time, right? So the tilt given to the orbit is equal to 26.7 and it has 27 subplanets. This is about the Uranus. Then finally Neptune, it is the planet which is located very far to the sun, right? It's the final planet in our solar system, my dear children. So 4,495.1 millions of kilometers is the distance from sun. Diameter in kilometers around 50,000, 49,528 to be exact, right? Around 50,000 kilometers. Then the rotational time is around 0.72 days, more than 24 hours, less than 24 hours, my dear children, right? Less than 24 hours, right? In days, 0.72 means less than 24 hours. Then revolutional time is given 164 years. Actually, when you round it off, it should be 165 years. 165 years, nearly 165 years. To be exact, 164.8 years, my dear children. A very large value. It's going to rotate around sun by taking 165 years. See the effect of gravity. Right. Then the tilt given is equal to 97.8, the tilt. Then the number of subplanet is equal to 14. Number of subplanets is equal to 14. So these are the information regarding to our planets. Okay. These are the informations regarding to our planets, my dear children, about the rotational time, the revolution time, the tilt shown to the orbital axis. Then after that, the number of subplanets. Okay. Right, my dear children. So these are the basic information, like these are the very basic information that we need to learn about our solar system, planets in our solar system. All of these information were gathered by scientists, right, from the ancient time period, my dear children, and for your easiness, they have been tabulated, and when you go further with the time, you may know that there are even more than these things. Okay. However, up to now, it's enough to study these basic stuff, and when you go to further grades, you may identify even way more different details about our planets. Okay. So with that, my dear children, I'm about to finish the first chapter related to the lesson, right? So within our next chapter, we'll discuss further things related to the lesson part.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.